now that we've investigated free fall, let's spend a little bit of time solving some free fall problems. Okay? First, a couple things to remember. Okay, an object is in free fall if the only thing causing it to change its motion is gravity, and we need to know a little bit about gravity. On Earth, the accepted value for the acceleration due to gravity is 9.8 meters per second per second. So that's what this little information here tells you. Okay, and you'll notice I don't have that written as negative 9.8 meters per second per second. It's just 9.8 meters per second per second. The reason is you get to pick your frame of reference. You get to pick which way's up, you get to pick which way's down, you get to pick which way's positive, which way's negative, whatever. It's up to you to decide. So pretty much every time I do a free fall problem, I want to draw a picture first and establish my coordinate system and my frame of reference. Okay? So let's do a free fall problem. We're going to do a couple of these, and then I have an assignment for you guys to work on. Okay? But example problems first. Okay? A water balloon is dropped from a height of 25 meters. How fast is the balloon going when it hits the ground, and how long was it in the air? Okay, now you've got to be very, very careful when you read this problem. Okay, it says how fast is the balloon going when it hits the ground? I'm not asking you to tell me how fast the balloon is going the instant after it hits the ground. I want to know how fast it's going when it hit. Okay, so the answer to that question is never going to be 0 meters per second. You've got to be very careful what information you pull out of this question. Okay? So let's start pulling information out. A water balloon is dropped from a height of 25 meters. Ooh, yuck. First, let's draw a picture. Okay? So here's my building, and here's the ground. And generally, I like to say the ground is at 0 meters, and that down is a negative direction. And this was my initial position, 25 meters high. So here's my picture. And now I've established a coordinate system. Okay? So, balloon is dropped from a height of 25 meters. That means I know an initial position. It started 25 meters in the air. But I also know an initial velocity. It didn't say a ball was thrown, it said a ball was dropped. And so I know its initial velocity, when it was in my hand, it was 0 meters per second. How fast, so I'm looking for a final velocity, question mark. How fast is the balloon going when it hits the ground? That tells me I know my final position. My ground is at 0 meters. And how long was it in the air? So I'm also looking for time. So I've got two things to answer. I need a velocity and I need a time. Where should I start? Well, if I start with that velocity thing, I know an initial position, I know a final position, I know an initial velocity, and I know one more piece of information. Remember, it's a free fall problem. The whole thing that's causing this to move is gravity. So G, except I picked it to be negative because down is negative. So negative 9.8 meters per second per second. Okay, so if I know the acceleration, I know an initial velocity, and I know a change in position, I can use the third equation. Final velocity squared equals initial velocity squared plus twice the acceleration times the change in. And you know what? I'm going to change this a little bit. Okay? I have x naught over here and x, except really I'm in the vertical direction, so instead of using x, I'm going to use y. So I have y naught and y. Okay? And instead of delta x, I'm going to have delta y. It's a good habit to call your vertical things y's because later we're going to put horizontal and vertical together. We don't want to get them confused. Okay? So final velocity squared equals initial velocity squared plus twice the acceleration times the change in position. Same exact equation we used to have, except we're using y's instead of x's. So I'm looking for v. I don't know it. Initial velocity is 0 plus 2 times negative 9.8 times the change in position. Be very careful. When you find a change in position, it's final minus initial. Well, the final position was 0, the initial position was 25, and so my change in position is not 25 meters, but negative 25 meters. So v squared equals negative 19.6 times negative 25. Okay? And if we do that math real quick, we see that we're going to take two negatives and end up with a positive. So 19.6 times 25 is 490. And so v squared equals 490 meters. That's not v, it's v squared, so we square root both sides. and we get v equals 21.6 meters per second. Now, you have to be very, very careful, because when you use the third equation, you square and square root. Okay, and remember, if I gave you x squared square rooted, the answer to that is not x. The answer to that is the absolute value of x. Okay, so it takes whatever you put in and makes it positive. So you have to be careful and you have to be vigilant. You got to pay attention to your question. Which way was this thing moving when it hit the ground? Well, it was moving down. So this velocity is actually the negative one, right? We could pick plus or minus, and we need to pick negative because it is moving down. So there's my velocity. That's how fast it's going when it hits the ground. Okay, I also wanted to know how long the balloon was in the air. Okay, and I can do that. All I have to do is say, okay, now I know an initial velocity, I know a final velocity. Now I can find time, because v equals v naught plus at. So negative 21.6 equals 0. Wow, that's almost legible, right? Okay, try that again. Negative 21.6 equals 0 minus, because the acceleration due to gravity is down, 9.8 times t. Okay, and so now I'm going to divide 21.6 by negative 21.6 by negative 9.8, and I'm going to end up with a positive time, which is good, because if I ended up with a negative time, I would know I did something wrong. So 21.6 divided by 9.8 equals 2.14 seconds. Okay. So it took about 2.14 seconds for this thing to fall, and it happened that this thing got up to a speed of 21.6 meters per second. Could you use the second kinematic equation to do this? Absolutely. You can try it if you want. If you have a question about it, let me know. Okay. I'm going to work one more problem, and then I'm going to let you guys get started. Okay. So this one says, all right, similar problem. Suppose the ball, balloon, whatever, from the previous problem was given an initial upward velocity of 12 meters per second. Find how high it goes above the ground and how fast it was going when it hits the ground. Okay, this is a little bit of a different problem because it has an initial upward velocity. It's still in free fall because the only thing that's going to pull it back down is gravity, but we have to pay attention to what's going on. So again, the ground is 0 meters. The building, or whatever this is 25 meters. Down, I'm still going to say is negative. Okay, but now I've got to be very, very careful over here because there is some other stuff going on. Okay, initial velocity, it was tossed up, so my initial velocity is positive 12 meters per second. My initial position, y naught, is 25 meters. Okay. The acceleration is the acceleration due to gravity, so negative 9.8 meters per second, and then how high it goes above the ground, right? So this ball, it's going to go up, and then it's going to come back down. Okay, it's a free fall problem, but there's this interesting part to it. Now, this is the trick to solving a question like this, when it wants to know how long it goes up or how high it goes. The question really becomes, well, what other information do I know? Because an initial position, an initial velocity, and an acceleration are not enough to get me all the information I need to solve this problem. I need one more thing. Well, the height it goes above the ground, I know something about this point, right? This is its highest point. At that point, remember when you toss the ball, okay, the velocity when it changed direction is 0 because it's not going up and it's not going down. So for the first part of this, I actually know my final velocity. My final velocity is 0 meters per second. And that's okay in this instance because it's not asking for the velocity when it hit the ground. It's when it's at its highest point. Since it's changing direction, its velocity is 0. Okay? So now I have enough information that I can actually find the final position, y equals what? Okay? And I have a couple options I could do here. I don't have time, so I probably don't want the first or second kinematic equations, although I could use both of them and work it out. But the third kinematic equation already does that for me. Final velocity squared equals initial velocity squared plus twice the acceleration times the change in position. Since it's vertical, I'm going to use delta y. So 0 equals 12 squared minus 19.6, right? 9.8 times 2 times the change in position, which I don't know. Okay, that's what I'm trying to find. So negative 144, if I subtract that over, equals negative 19.6 delta y. Divide both sides by 19.6, and we end up with, let's see, 144 divided by 19.6. We end up with 7.34. Yeah, that sounds right. Delta y equals 7.34 meters. Now, that's not the answer to the question. Okay, that's the change in position. That's this distance right here. This is 7.34. Okay, so the height above the ground is going to be 25 plus 7.34, which is 32.34 meters. Okay? Alright. Now, this second part, how fast is it going when it hits the ground? Okay, now I've got to be careful because I have said when it hits the ground, and that's not 0. I've got to look at the whole time interval. Okay? But I can still use, well, can I use this one? V equals V naught plus AT? No. I know its initial velocity. I know its acceleration. I do not know this, and I do not know this because I'm looking at a different interval. So that equation's out. What about final velocity squared equals initial velocity squared plus twice the acceleration times the change in position? Oops, delta y. Can I use that? Well, let's see. What do I know? I know an initial velocity. It was tossed up at 12 meters per second. I know the acceleration is negative 9.8, and I actually do know its change in position. Over the course of this thing, it moves from 25 meters to 0 meters. So this is negative 25. Why isn't it negative 32? Well, because change in position is just starting to ending. Okay? If I wanted its change in position after the highest point, that would be one thing, but then my initial velocity wouldn't be 12, because at its highest point it would be 0. Okay? So as long as I'm picking my initial velocity to be 12, then I've got to start my initial position at 25. Okay? So v squared is equal to 144 minus 19.6 times 25. Why do I feel like I should know what that is? Yeah, oh well, I'll try it. 19.6 times 25 equals 490. That's why I felt like I knew what that was. So 144 v squared equals, 12 squared, which is 144, plus, right, because a negative times a negative is 490. And so now I have v squared equals 634. And if I square root that, I get 25.18 meters per second. But again, when you square and square root, you got to pick them a positive or negative, and I'm negative. Okay. All right, try those problems out of the book.